Hi, good morning to one and all. Myself, A. Ramanjani. Today I am going to explain about new topic, that is torsion. Mainly this topic will help to find out different types of powers transmitted from one shaft to another shaft. Okay, in that case we need to calculate what is the amount of power transmitted from one shaft to another shaft. So that in this chapter we will discuss about what is the torque, torsion and power transmitted. Okay, all these terms we will discuss in this class. Okay, coming to topics to be discussed. Okay, that is in this unit we are having mainly two topics, that is torsion and springs. In torsion we will discuss about torsion formation, stress and deformation in circular and hollow shafts. Okay, generally we use circular shafts of solid and hollow. In some cases we use different cross sections. Okay, mainly we use circular shaft having solid and hollow sections. In some cases we use stepper shafts. Next, in this chapter we will also calculate the deflection in shafts fixed at both ends. Okay, next second section, that is springs. We will discuss in this springs topic, that is what are the different types of springs and what is stiffness and what are the deflections, costs and types of loads. Okay, all these topics we will discuss in this topic. Okay, coming to torsion. Okay, before knowing the what is torsion, we need to discuss the what is shaft, where it is used. Okay, shaft is an element, mechanical element. It is used mainly in power transmission area. Okay, we need to transform the power from one point to another point. Best example, that is bicycle. Okay, we all know about bicycle. Okay, we are giving input by using our legs as a pedal. Okay, that energy is transformed from pedal to rear wheel. Okay, with the help of chain. The chain is a transfer medium. Here the power is transformed from input shaft to output shaft by using the medium is, here we are using chain. Okay, in that when you ride a bicycle, how to we transfer power from leg to the pedals and through shaft and chain to the rear wheel. Okay, in the same criteria, coming to car. Okay, here the transmission system from input to the output is shaft. That means the power coming from the engine is supplied to the rear wheels. Here we are not using any chain system. Here we are using a shaft. Okay, by using the shaft we are transforming from power from the engine to the rear wheels. Okay, here in this case the power is transformed from engine to the wheel, requiring many shafts that form a drive track. Okay, next here observe, this is the example. This is a vehicle, front wheel and rear wheels. Here having engine. The power from the engine is transferring to the rear wheels with the help of shaft. Okay, it is the need of shaft. Okay, and whenever we giving the force at the input area, what happened? Some amount of force will develop in the input section. The same amount of power will transfer to the rear wheels. During this process, some amount of resistance will develop in the shaft. Okay, that means we are applying a force tangential to the axis or tangential to the shaft. Okay, due to the application of force, some torque will be developed. That means torque is equals to force into distance. Okay, we are applying a force at a distance from axis. Okay, that means force into distance is nothing but torque. Okay, observe in second diagram, it is the engine and it is the differential box. Here in this, these two are connected by a shaft that is known as driving shaft. whenever we give the energy at the engine input shaft, that same energy will transform to the railway with the help of driving shaft. Okay, during this process, whenever we give some input torque, okay, the same torque will transform to the differential. Okay, next, coming to the helicopters, the helicopter blade will rotate by taking the energy from the engine. Okay, this is one of the example. Next, coming to the shaft, any structural member that transmits torque from one plane to another is known as shaft. Already we see number of examples, that is in automobile and helicopter. Okay, in machineries, in everywhere we are using an element to transform power from one shaft to another shaft, one point to another point with the help of shaft. Next, a member is said to be in torsion when it is subjected to twisting moment about its axis. Okay, suppose whenever the vehicle or machinery is without rotating or without moving, what happens? The shaft is ideal. Whenever we need to move or start the engine, what happens? The input, we are giving some input. Due to this force, that means input force, some twisting moment is developed in the shaft. It is known as torsion. Next, observe here. I'm giving one more example. That is, twisting moments or torques are forces acting through a distance so as to promote a rotation. Okay, we need to rotate, assemble this screw, bolt and nut. Okay, for that what we are doing, we are applying some amount of force to the bolt to tighten. That means application of force is here, and the distance from application to the applied force having some distance. Okay, by multiplying the applying force into that radius is known as the torque. Okay, next, coming to the torsion. Torsion is the twisting of a straight bar when it is loaded by twisting moments or torques that tends to produce rotation about the longitudinal axis of the bar. Okay, for example, when we turn a screwdriver, what happened? To produce, applying some force, rotational force with a certain distance. Okay, our hands applying torque to the handle and twist the shank of the screwdriver. Observe, we are applying some amount of force by using our hands. Okay, that amount of force to the center of the axis of the screwdriver. Okay, by multiplying the force into the distance, that's nothing but we are applying twisting moment. Okay, that twisting moment is known as torsion. Next, general in engineering problems, many members are subjected to torsion. Example, shaft transmitting from engine to the rear axle of automobile, and from a motor to machine tool, and from a turbine to the electric motors are the common example of members in torsion. Okay, next, a common method of transmitting power is by means of torque in a rotating shaft. Okay, it is the common method. With the help of rotating shaft, we are transmitting the torque from one point to another point. Okay, next, observe given one example, that is transmission of power from motor, electric motor to the pump. Observe, it is the input power coming from the electric motor. That input power is transforming by using circular shaft to the pump. Okay, in this medium it develops some amount of torque. Okay, next, here given one more example, that is turbine and generator. We all know that the application of turbine and generator. Okay, with the application of turbine and generator, here the generator
give some energy, get some energy from turbine. Okay, whenever the turbine rotates, the input that power from the turbine to the generator is transformed by using with the help of shaft. In this case, at point A and point B develop some amount of twisting moment
due to the torque applied at turbine and okay. Generator creates an equal and opposite torque. What are the amount at the input area? The same amount of torque will develop in the generator side, so that the same amount of power will transform from input to the output. Next, bars subjected to torsion. Let us consider a straight bar supported at one end and acted upon by two pairs of equal and opposite forces as shown in figure. Okay, here I taken one example. It is the fixed end, it is the shaft. The shaft is connected at fixed end and end having, we are applying two forces P1 and P2. Okay, at P1 from fixed point to this point having some, we are applying some force, that is P1 with a distance D1 between the two ends. Okay, so that the torque is T1 is equals to P1 D1. Similarly, at point 2, at the end of the shaft, we are applying some force P2 with the distance D2, so that T2 is equals to P2 D2. That means we are applying force at two different directions. That means it is develop some twisting moment. Okay, that means it is resisting some amount of whatever the applied force, it offers some resistance. Okay, next coming to the definition of torsion. Okay, when a pair of forces of equal magnitude but opposite direction acting on a body, it tends to twist the body, is known as twisting moment or torsional moment or simply as torque. Okay, next, in case of circular shaft, if the force is applied tangentially and in the plane of transverse cross section, the torque may be calculated by multiplying the force with the radius of shaft. Okay, that means whatever the amount of applying force and multiplying with that radius, that means center of the axis of the shaft to the applied force. Next, coming to pure torsion. Okay, up to now we discussed about torsion, that is nothing but whenever we are applying a force at both ends. Okay, equal and opposite forces develop on a shaft. What happened? It offers some resistance to the applied force, that is known as pure torsion or twisting moment or torsion moment. In the same way, coming to pure torsion, a member is said to be in pure torsion. That means its cross sections are subjected to only torsional moments and not accompanied by any axial or bending forces. Okay, in some cases, what happened? The shaft is subjected to both twisting moment and axial loads and bending moments. In that case, the shaft is in torsion only. Whenever you have to use the word pure torsion, is nothing but the shaft subject to only the twisting moment. It is not subjected to any axial or bending moments, so that it is known as pure torsion. Okay, it is about what is torsion and when the shaft is subjected to twisting moment and how to calculate the torque. Okay, and what are the different applications of shafts. Okay, in next class we will discuss about simple torsion theory and derivation of torsional equation and units. Okay, thanks for watching.